Hello, Coach Travis here with another trigonometry video. So the question here is to find the coordinates of the point on the unit circle at an angle of 11 pi over 6 radians. Okay, so essentially this question is asking us what's the sine of 11 pi over 6 and what's the cosine of 11 pi over 6. Because that's how you define sine and cosine, right? Is you draw your angle and you see what the x and the y coordinates are where it crosses the unit circle. So the sine is the y coordinate and the cosine is the x coordinate. So this is just sort of a weird way of asking what the sine of 11 pi over 6 and what the cosine of 11 pi over 6 is. So all right, so how are we going to do this question? So the idea here is the way some students answer this question is they memorize the entire unit circle. So if you memorize the entire unit circle, then this question is very easy because, hey, looky there, it's 11 pi over 6 right there. And so from right there, I can see what my x-coordinate is, I can see what my y-coordinate is, and I'm all done. So that's great. If you can memorize the entire unit circle, then good for you. I think that's great. However, personally, I think there's an easier way. That's a lot to memorize. I don't memorize that whole thing. I think there's an easier way. And kind of a better way. And that way is instead to use reference angles and to use special triangles. And these are the two special triangles that we use. So what I'm saying is that everything that you can do with the unit circle, you can also do with just these two triangles. So if you're able to memorize these two triangles, then anything that someone who memorized the entire unit circle can do, you can do. And there's a lot less to memorize, and you're less likely to memorize things wrong. And so I kind of just think this is a better way. So all right, so let's go back to the problem then. So the problem was find the coordinates of the point on the unit circle at an angle of 11 pi over 6 radians. So okay, so first thing I need to do is I need to draw the angle. And again, I'm pretending I don't have the unit circle memorized. So I need to figure out, well, what is this going to look like? What is 11 pi over 6 going to look like? And the way I think about it is I think about 11 pi over 6, I look at those numbers, and I say 11 pi over 6 is very close to 12 pi over 6. And you say, well, why did you pick 12 pi over 6, Travis? And the answer is, well, because 6 goes into 12 and a whole number of times. 6 goes into 12 a whole number of times, twice. And so this is going to be a nice number. But 11 pi over 6 is not quite this. It's only off by a pi over 6. So I have this equation right here. I can say 11 pi over 6 is just 12 pi over 6 minus a pi over 6. And what I like about that and why that's helpful is that, like we said, this was a whole number of pi's. So 12 pi over 6, that's the same as 2 pi. And so 2 pi minus pi over 6 is equal to 11 pi over 6. So this is telling me what my picture is going to look like. What my picture is going to look like is I want to go a complete revolution. A complete revolution, my computer won't let me do it. A complete revolution is 2 pi. But then, oh, but we don't quite go a complete revolution. We miss out by pi over 6. So we kind of we go just short of a complete revolution. We go pi over 6 short of a complete revolution. Aha. So I maybe would even make a note of that in my picture. I would say this angle right here, that angle right there is pi over 6. Because that's how short of a complete revolution we are. So all right, yeah, so just so we label everything here, the big green angle, that's 11 pi over 6. So 11 pi over 6 is that big green angle. And then pi over 6 is that little red angle. And so notice when you put them together, you get a complete revolution. Okay, so now at least I know what this angle looks like, and so it's going to be in the 4th quadrant. Okay, but now how are these? Where are these special triangles? How are they going to help us now? So let's go back to the special triangles. And so what I'm going to do now is this is a reference angle. This is the reference angle, right? The pi over 6 is the reference angle for the angle 11 pi over 6. Because pi over 6 is the acute angle formed between the terminal side and the x-axis. So pi over 6 is the reference angle. And now what I'm going to do is I'm going to draw a triangle. Okay. So I'm gonna drop a perpendicular down or up. I'm gonna draw a perpendicular right there, and then I think I can highlight it. That might make it easier. What we got here is we've got a right triangle. Oh my gosh, I'm really shaky today. I have to apologize. I would say too much coffee, but I don't drink coffee, so I don't know why I'm shaky today. Maybe it was I don't know. So anyway, we got this green triangle there, and so what? Well, the point is that this green triangle is one of these special triangles. If you look at this green triangle, you'll see that, okay, one of the angles is 90 degrees. One of the angles is pi over 6, and that means the third angle is determined. And if you look at this triangle, sure enough, it's got a 90-degree angle and a pi over 6. And so this angle and this angle have to be the same because we know that all three angles have to add up to 180 degrees or pi radians. So this angle has to be pi over 3. I'm not going to bother writing it down though. So the point is that this triangle is right here, just in rotated form. So what that means is, since I have this triangle memorized, and oh yeah, I forgot to mention this, but we know this is the unit circle. So we know the hypotenuse is 1. So yeah, so this triangle is exactly the same as this triangle. And so let's look at this triangle. The short side has length 1/2. So the short side has length 1/2. And the long side has length square root of 3 over 2. So all right, so now I think we know the coordinates of this point now. Because remember, that was our ultimate goal, right? Our ultimate goal was to find the x and y coordinates of that point right there. And we now know, okay, well, the x coordinate is we have to go the length of this horizontal side, which is the square root of 3 over 2. And then to get the y coordinate, we have to go down by a length of 1/2. So down by 1/2 means negative 1/2. And so there you go. So we got the coordinates of that point. So we can now say that we know that the sine of the angle is the y coordinate. So this is going to be negative 1/2. And the cosine is the x coordinate. So this will be square root of 3 over 2. And there we go. So we got it. And so notice if I go back to my unit circle, you can see that, oh yeah, okay, that's exactly what the unit circle predicted. What we did was we just figured out what the unit circle already said, but we figured it out. We didn't have to memorize this whole thing. All we had to know in order to figure it out was we just had to know this triangle right here. We had to know all three sides of this triangle, and we had to be able to find reference angles. So there you go. So if you can find reference angles and you've memorized these two special triangles, then I promise you everything that you can do with the entire unit circle, you can do with these two triangles and reference angles, just like we did in this example.